So I'm going to talk about insert sort, runtime complexity in the best and average runtime. I think is what I just told you. Yeah, best and average runtime. I did a worst case in my last video, so best and average. As a review, the worst case, worst equals n squared. Why was it n squared? Because you're making n comparisons to, taking n elements, comparing it to n minus 1 other elements, but then to account for the fact that when you start with just one comparison and you end with every comparison, and then on the way you're making one more comparison each, you're doing half of what this total is. So divide that by 2. You drop the constants and you get n squared. That's just a quick review. Okay, let's get to the best and the average runtimes, which I've actually felt were actually more fascinating and more interesting than worst case. So best case, you have 1, 2, 3, 4. 2, you compare it to 1, that's it, no extra work. 3, you compare it to 2, no extra work. 4, you compare it to 3, no extra work. Yes, it's a small sample, or a small data set for the example, but it tells you that that's n, so n minus 1, make for that bigger, n minus 1, drop the constant. So now that's just n. So best case is n. Average runtime. So here's the thing about average runtime. You have to consider it's randomly, a set of randomly generated numbers. So randomly generated numbers. And with the randomly generated numbers, you're going to have a set where you can say that after looking at each number, half of the numbers to the left will be less than it if it's random. So half the numbers to the left are less than, half numbers to the left are less than the current index value. Granted that you're only gonna have to move half the time, right? So, or swap half the time. So that would be n times n over 2. Or the same thing, n times n times a half, which would be the same as n times n over 2, easier to look at. Drop the constant, that equals n times n, which equals n squared once again. So n squared, that's the same as the worst case. Worst is also n squared. Ain't that a thing? So we have best is n, average is n squared, and also worst is n squared. So that's about it. I just thought that was kind of interesting how it goes, because of the nature of asymptotic notation, and also I'm sure there's mathematical proofs that I'm not going to get into right now. But yeah, average and worst case. Insert sort. According to asymptotic notation, they're the same. I'm sure there's ways you can prove it, ways you can say, well, in the average case, actually, it's not quite as bad. But like I said, I'm not a mathematician. I'm just a computer scientist and a programmer. So have a great day, guys. Hope you enjoyed it. I'm going to just keep making these videos. And have a great day.